Okay, I am not with you today, but that does not get you out of having to do a warm-up. So if you would please pause the video, I would expect to see several boxes on your paper as you were multiplying the following, and then finally find the degree of this binomial. Pause your video. Okay, so these first two were pretty straightforward. We multiplied and got the following. Check your answers, make sure you have exactly what I have. But notice on this third one, I actually have a four-term polynomial. If you go up and look at the box, I had, even though I was across my diagonal here, I had two different terms because here I've got a y squared and here I've got a y term. So I wasn't able to combine these terms even though they were on the diagonal. So do be careful when you're multiplying, even using the box method. It may not be quite as perfect as you think. So I did end up with a four-term polynomial. Question is, find the degree of the following. Hopefully you have this. This is a fifth degree binomial. Why is that? Because I've got a y cubed. Remember, I don't have anything here, but of course this would be a 1 and a 1. And if I add the degrees of all of my terms in the highest term, I've got a fifth degree binomial. This x term was only degree 4, so this first term is the higher degree. Okay, so today we're going to be talking about special products of binomials. So I've got this square and it's got a side length of AB, and obviously the other side is also AB. It is A plus B, it's a square. So if I were to, kind of like using the box method, look at the area of each of these pieces, well, I break this up so that this is just a side length of A and A, or A squared. This is my b squared down here in this corner, and then I've also got a length of A and a short length of B, so that's AB, and that gives me the same piece here, or AB. So notice when I've got two binomials that are exactly the same, or A plus B squared, I've got A squared, I've got that b squared down at the end, and then I've got two of the AB rectangles. So what pattern do I see? Well, I'm squaring this first term. I'm taking the product of those two and I'm doubling it. I've got A times B and I want two of them. And then I'm squaring the final term. So let us look at this perfect square. I've got x plus 3 and I'm squaring that term. So, okay, if I really thought about it, that's really just x plus 3 times x plus 3. Remember, I told you I can't distribute this squared term because I have an operation inside. I can only do that when I've got a monomial. So I could just set up my box method or use FOIL to find the product, but I've got this shortcut now. I know that I'm going to square that first term. I'm going to take the product of these two terms, 3x, and double it. So I'm adding 6x, and then I'm taking the square of the final term, or 9. So x plus 3 squared is x squared plus 6x plus 9. Again, if you would prefer to write it out, do the box method or FOIL, I am totally okay with that. Next, try this one on your own. So go ahead and pause the video and see what you come up with. I would have 5 plus m squared times 5 plus m squared. So I take the square of the first term, the product of the two, 5m squared, and I'm doubling that, so I get 10m squared, and then the square of the final term, m to the fourth. So of course I'm going to write this in standard form, so I'm going to switch everything around so that I have m to the fourth plus 10m squared plus 25. So what do you think is going to happen if I have a difference of squares, x minus 6 squared. Well, again, that's still x minus 6 times x minus 6, and I can box method that or FOIL method that. But what I'm going to see is that I'm squaring my first term, and then I'm going to find the product of those two, negative 6x, but I'm going to have two of them, so negative 12x. And then because I'm squaring that last term, which is negative, it becomes a positive 36. Okay, so what does that look like as a rule? You are welcome to pause the video and write these down. I think they'll become fairly familiar to you. A plus b squared, the first term squared, plus the product of the two terms, and double that, and then add the second term squared. If I've got a difference of squares, then I've got the first term squared minus the product of the two doubled plus the second term squared. Again, it's not necessary to memorize these, but it is helpful. It's a shortcut for later. All right, so now I've got one more situation. Notice this is x plus 4, and then I have an x minus 4. Well, what's going to happen? Again, I could box method or FOIL this. So what you see is, and I went ahead and did this as a box method, I've got an x squared term, so my first term is squared, but then I've got a negative 4x and a positive 4x, which are going to cancel each other out. So because I have a plus and a minus, those middle term cancel each other out. And then finally, I have a negative 16 because of the minus sign here. My squared second term gives me a negative 16. So it's kind of cool how the middle term disappears because I had a plus and a minus. Why don't you try this one on your own? Pause the video for a minute and come back and check out the answer. So again, my middle term is going to drop out. I'm just going to have my first term squared, so p to the fourth, minus, going to make this a negative, and square the second term, 64q squared. So special, the difference of two squares is going to give me the first term squared minus the second term squared. Just kind of cool rules that shorten your work just a little bit. Okay, so now we're going to apply a little bit of geometry to our polynomials. We want to find the area of the yard around the swimming pool. So here I've got my swimming pool and I've got my fence all the way around on the outside, and I want to find out how big my yard is. Well, if I'm looking for my yard, obviously I'm going to find the area of the rectangle of the fenced area. Actually, this guy is going to be a square. And I'm going to subtract from it this smaller rectangle. So how do I do that? Well, I have all these special products that I'm going to use. The area of my big square is x plus 5 squared. And I'll let you come up with that one real quick. Okay, so of course I've got this squared, I've got the product, and I doubled that, and the final term squared. And then I'm going to subtract from it my rectangle, which was x plus 2 and x minus 2. So of course my middle term will drop out, leaving me my x squared minus 4. And then I'm going to use my properties that I learned with adding and subtracting polynomials. I've got x squared plus 10x plus 25, and I'm subtracting from it this smaller rectangle of x squared minus 4. So go ahead, pause the video really quickly and come up with your final polynomial. So I got rid of my parentheses by making my x squared term a negative, distributed my negative, and my 4 became positive. Notice that my x squared terms canceled out, leaving me with 10x plus 29. Okay, That's going to be really useful next week. You can work on your animal tracks. Whatever you don't get done is homework. And you also have a con for tonight and a video. So get started.